Hi, I'm Chris Young, Chief Technologist covering MicroFocus's strategic accounts. In today's presentation, I'll cover a problem that's common to many organizations, the lack of skilled performance engineers. And I'll be discussing how you can use a combination of automation, AI, and shift left or shift right methodologies to have computers fill in that void. Think of it as a virtual performance engineer. If you're going to have a bot fill in for a human, it's important to understand what that human does. And in the case of performance engineers who help QA how applications respond under load, they conduct four major activities. First, they work with developers and QA analysts to build and record scripts that simulate user load. And then they push those assets up to the execution platform to generate load against that application under test. Then they collect and analyze the data generated to determine response time patterns. And finally, they consult with developers to identify and alleviate bottlenecks, increasing that application performance. And so if we look at this in two phases, really we have everything on to the left that we'll call build and everything on the right that we'll call analyze. And in today's video, we're going to cover the build aspect. Many companies today rely upon microservices to deliver their applications to market. And Swagger Open API, this logo, has become the default standard for documenting microservices. And Swagger has a robust ecosystem of libraries that help developers design, build, document, test, and consume RESTful web services. And you may have seen self-documenting help pages like how MicroFocus documents all of our web APIs. When you click on one of these individual banners, it brings up the documentation for a particular endpoint where you can, stub out some sample code, even use a little button to try out that API call. So once you have documented your API in Swagger in this JSON format, you can include those libraries directly in your web pages and you'll end up with documentation just like this. So one of the other cool features behind Swagger is since Swagger documents those APIs and we can render self-documenting help, we can use that same concept to roll through those documents and use AI to generate unit and functional and load tests directly in the hands of developers without requiring a performance engineer. In this video, you'll hear me refer to this as the gadget. So let's quickly cover the process flow for the gadget. So you have a developer. They're working in Visual Studio, Eclipse, or IntelliJ, and they're developing source code and unit tests of that source code. Then you have your CI/CD tool chain, which consists of a source code repository in Jenkins. And as the developer checks in code, Jenkins sees that check in and then builds that against a test environment. Now it's pushed over to the QA team, who is now going to qualify this application candidate. And so they take those unit tests that were created by the developers and they derive functional SIT or UAT tests from them. And then the performance engineers come in, actually take those functional assets, run them at scale, many copies of them against the test environment. And they do that using Load Runner or Performance Center from MicroFocus. Now, one of the interesting characteristics is to build these scripts, it really takes a skilled performance engineer who's got knowledge of the product as well as some time in order to create those scripts. And this can frequently bottleneck the CI/CD process because the developers are able to check in code faster than the performance engineers can keep up. So to move away from this, this is where the gadget comes in. We put an easy button in the hands of the developers, and every time the developer, changes the Swagger, the easy button is run and it creates a new performance test derived from that Swagger, automatically uploads it to Performance Center without any human involvement. And now you can remove the performance engineer from the equation. It frees up the CI/CD process, and really what you're doing is you're shifting this burden left onto the developers. They're able to load test much earlier in the process against their own machines. And you're also enabling it so that the performance engineer is out of the mix and the human bottleneck is gone. And now Jenkins, every time someone checks in code, can run a performance test. If it passes, it moves it on through the process, therefore enabling continuous deployment. Now, before this video dives too deeply into the gadget, let's talk a little bit about script creation and how we can create that in any set of toolkits. So if you're an admin or a developer and you log in to LoadRunner or Performance Center is the on-prem version, you'll see a little splash page where it's a quick start. If you don't have a script, you can use some common tools to create a script. And so if you have a HAR file that you've maybe recorded inside of the Google Chrome tools, or maybe you have a REST endpoint, there's a wizard where you can type that endpoint in and test it. Or maybe you have a series of endpoints with the data you need to post to them inside of a CSV file. You can upload that Excel and it will automatically create you a script. It also has the capability to accept other common open source formats like Vuegen, Gatling, or JMeter. Selenium with JUnit is supported, as well as MicroFocus UFT scripts. You might even use, if you're familiar with Node.js, we have a library called TrueAPI that allows Node developers to develop their own code. But what we're going to be using in today's video is something called DevWeb, which is a series of utilities and plugins directly to the developer's IDE that allows them to use standard JavaScript to develop performance scripts. So no matter what tool you create your script, LoadRunner or Performance Center is smart enough to figure out what type of asset it is, and it will automatically upload it to the asset library. And as you can see, it will derive the type here, and then that'll be available for developers or Jenkins to use. Here is a little how-to if you want to learn a little more about each of these different script types and how to implement them. But again, we're going to be covering DevWeb, which is will allow you to use any standard IDE and real basic JS files to create your scripts. Now, the gadget was designed with a couple design principles in mind. First off, it's cross-platform. It's able to run on Windows, Mac, or Linux. And the developer will be able to use whatever IDE they're most familiar with. It's all API driven, so if you feel comfortable with REST APIs, you can certainly extend it to meet your needs. It's written in JavaScript, so it's a ubiquitous language that's familiar to most developers. Again, as I pointed out in the last slide, toolkit agnostic, so we don't really care what you originally create your script in, whether it's Selenium, Gatling, HAR files. And then finally, everything that the gadget does is meant to minimize clicks and take away those mundane tasks that the developers might become bored with. So let's jump into a demo of the gadget. For the demo, let's get you oriented to my setup. So as you can see, I have Chrome open and I have 3 tabs. The first is a link to my LoadRunner Cloud interface. As you can see, I've logged into a particular tenant ID. Here was that splash page that I showed a couple slides ago. And underneath here, you can see all your catalog of load tests are here, and any script assets that you've uploaded are available here. The second tab that I have is a Swagger editor. This is a Swagger file that I'm going to be using to demo against. You can see it uses 2 public-facing APIs. We'll jump into the details of those a little bit later on, but this is a public-facing API that you can use in your tests for examples. The next thing that I have is a GitHub site, and you can see there are 2 projects here. There's LoadRunner Enterprise and LoadRunner Cloud. Each of these is for each of the 2 versions of LoadRunner. If you're using the cloud version, obviously download the cloud project. If you're using LoadRunner Enterprise or Performance Center, then use this particular project. I know that this LoadRunner Enterprise will work with LoadRunner Enterprise 2020 which is the current version at the time of this recording. It's also backwards compatible with some versions. I know that it runs on 12.6.3 of Performance Center as well. It may run on earlier versions, but you'll have to test. In addition to that, you can see that I've grabbed the LoadRunner Cloud instance and I've created a Visual Studio project off of that. That's a simple node project. Here is my app.js. And you can see this app.js is the basis of how we're going to run and create our Swagger file and upload it to the LoadRunner instance. So up here, let me go ahead and get started. I'm going to show you a full end-to-end transaction, which is going to happen in 2 parts. The first thing I'll point out is after you download this, everything is available inside of a common JS module. And all you have to do in order to instantiate it is basically just use the require function and set that to be a variable. So I've got a variable here, LR, that's going to point to this LoadRunner Cloud JS file. And then the next thing we have is a little configuration. As you can see, here's my configuration where I put my LoadRunner Cloud server, the tenant ID, which matches this information up here. In addition, I'm going to put the user ID, which I'm logging into the tenant with. I set that all up inside of my config file, and my app.js is going to take advantage of that config file for the configuration. So step one is we're actually going to parse a Swagger file into a DevWeb script. So in this case, you can see that we have a little function here called run no prompt, which is going to inside of that common JS module, we have a Swagger object with a toDevWeb method. And if we hover over this, you'll get the IntelliSense here. You can see that this method takes two parameters. First is a source. So this is where we point it to our Swagger file, either in a JSON or a YAML format. And then the second is the path destination that we want to output this to. So where do we want the DevWeb script to write to once we're done? So you can see I've got two examples here. Here's an example if we were testing against like a local JSON file. So I could go inside of this test and I could run it against this JSON, or I can actually go against a URL if it's available and is completely published. So in this case, I'm going to go to my website and download it directly from a JSON on the web, and then it's going to create me a new directory called test/Swagger example. So you'll see a new directory get created inside of here. Now once that process is run, the next thing it's going to do is prompt me for my LoadRunner password. And then as you can see, there's a second method here, which is going to take that script that gets created in the little first pass, in the first step. It's going to take that script and go ahead and push it up to the cloud and then run the script. So if we hover over this method here, you can see this push to cloud method. It takes the source directory, whatever we created here, and then we can see what we want the asset name to be, what we want the test name to be, and then a true false value of whether we want to go ahead and run the test. So you can see I'm gonna take that directory that we create from step one, and we're going to go ahead and push that up to the cloud. We're going to call it gadget script, and it's going to drop into my asset named gadget script, and then it'll create a load test that points to that, and it'll call that gadget test, and it'll go ahead and kick that off. So we're gonna run this all in one swoop. So go ahead and save that. Go into our terminal, run task, and we'll do a little node run here. And as you can see, it has now created that folder called Swagger example. It's prompted me for my password to LoadRunner Cloud. I'm going to go ahead and enter that, and you'll see that it goes ahead and pushes this up to the cloud. You'll see that it's going to return some values here with details about the new load test and asset that it created. So if we come over here into our assets, you can see it created that gadget script. It's also created the gadget test. You can see it's already kicked off that test and is initializing that test. So if we go into the gadget test, you can see gadget test is bound to the script. It's 5 V users for 40 seconds. That was right here in my config file, right? We see this 5 users for 40 seconds, and then it's gone ahead and created me a script. So I'm going to pause just for a moment while this initializes. Let me show you the interface here. It's going ahead and creating, it's generating all the load tests and the load generators it needs to go ahead and run this test script. So you can see it's doing it in the AWS cloud. And I'll pause just for a few moments here until this test initializes. You'll see this test run, and then it will email me when it is done. So after the brief pause, you can see now my load test has initialized and we're running. You can see here's the number of V users that has that's gone up. We've got some throughput here. You can see we're doing so many kilobits per second and so many hits per second over here. You can see that it's running. And then inside of that script, there are actually two transactions. There's two functions inside of here. There's an all uppercase with token. You can see that's been, executed 103 times, and then there's a number to word function, and as you can see, these are climbing up. So this is going to run for just a few moments, and then the test is going to automatically stop after the 40 seconds of execution, and then it's going to email me when we're done. So after that brief pause, you can see that our load test has finished, and if we go over here, we can see a report out of the number of transactions that were run. At the same time, LoadRunner emailed me this email here, and you can see it's a PDF of essentially what we're seeing exactly on the screen. I'll go ahead and bring that over here, and here's my test. You can see the number to word function and the all uppercase to token function. It ran those 115 times, and this test passed. So it's both emailing me, and it's providing me a visual report that I can download online. So now that you've seen how to take a Swagger file, generate a load test against it, upload it to the cloud environment, and run that test, let's go and unpack what you've seen. So as we talked about beforehand, we had sort of a two-step process. We had step one, which was actually parsing the Swagger, and step two, which was pushing it up to the cloud. So we'll cover these independently. So the first piece I'm going to talk about is how that DevWeb script was created. So inside of here, you can see there's a method that's called toDevWeb, and we essentially gave it a Swagger file, either in a JSON or a YAML format, either a local file or a URL pointer to a file on a web server, and it was able to go grab that and pull that down. Now here is my Swagger editor, just to kind of give you a little bit of an overview. There are two public-facing APIs that I use to create this. Again, there's these are public-facing. It's on data access. You can see there's a number conversion. You'll see this. The idea is there's an endpoint that's called number to words, and if we provide it an input of 10, it will output the alphanumeric wording of that. So let's go ahead and click on that and kind of show you how this works. So if I go into this service and we go to the number to words function and we feed it a number, let's go ahead and plug in 17. We can see that if we invoke this, it's going to return us a value that's going to be 17. All right. And likewise, we have a second service here that's a text casing service, second endpoint. And what this will do is it will change a string to uppercase, adding a token between letters. So if we fed it 10 and we fed it a delimiter of dash, it would output something like this. Again, just to show you this this guy, if we go into the all uppercase with token and we feed it a quick numeric such as 10, and we put a dash and we invoke the service, we'll see that it will go ahead and execute and provide us this output. So what I have done is in my Swagger here, I have created references to each one of these. So you can see here's our first path. It's that number to word function. Here's a little description of it and all the parameters that it takes. Here's that all uppercase to token with all of the details. Now, what happens inside of our code, as you can see, we converted that Swagger that we have over here, we converted that over into a test directory. If we open this test directory, you'll see this is our main script along with some supporting files that are inside of here. So it's plain old JavaScript, and you can see up here at the top there's basically some wrappers that define how the script is run, and it will run through this script serially. So you can see here's our first function, and if we go over here, you can see it's the number to word function. We're grabbing off the name as well as the description. It's translating it over here into a JavaScript comment. Then it's creating us a little transaction function so that we can create sort of a timer and start and stop that stopwatch on our response times. Then you can see it's basically loading a web page with a pointer to that endpoint there. So here's our endpoint. And then you can see we've got some headers, and it's pulled out, a header named foo with a default value of bar. It's plugged that inside of here, as well as created a stubbed out body. You can see that UBI number. If we scroll down here to the bottom, there is, number to word, a UBI with a default of 0. So everything is getting translated. Basically what it's doing is it's taking the Swagger, looping through all of the Swagger endpoints, and creating a simple JavaScript that executes that web request. And it's done that for both of our endpoints inside of the Swagger file. So, the first endpoint was the number to word, the second was the all uppercase with token. And then it's wrapped those into transaction start and stop times. Now, everything inside of here is pretty simplistic, and there are a whole set of utilities that are built into the IDE, or utilities that are able to integrate with the IDE to do local testing. So again, I had mentioned earlier that we can obviously run this up on the LoadRunner Cloud interface, but one of the neat features behind DevWeb is that as a developer, I can run a load test against my local workstation without actually having to push this up to the server. I can run this locally, debug and test it locally. And so one of the things that I've done inside of here is I've created a little profile that when I'm on one of these JavaScript files, I can actually run this thing as a quick sample run. So you can see we got a DevWeb, a single run. So I'm going to run this script and have it run through. So you can see it's going to go in here and do each of my timings. So you can see it pulled down that first piece, and here was our UBI number of 0. Let's go ahead and instead of using these defaults, let's put a little tester in here. Let's do this as 13, right? So we can see some of the zeros here. And just on this one, we'll do the 10 and just see what we get. All right. So we'll go ahead and run that as a little test again, a single run. And you can see that it's running our 10 there. There was our 13, and it pulled that back from our UBI number. So we're dynamically creating this and testing it on the fly locally without me actually having to push the script up to the server. So this is a great way for developers to perfect their script locally before they push that thing to the cloud. So there are a couple other neat little features that are inside of here that will help a developer sort of do his load testing. So you can see obviously we were able to go in here and when the Swagger stubbed out, it used the default values. But let's say we wanted to use, like maybe we wanted to feed these in from an Excel file. Well, this particular template that's written here, and it's completely customizable. Everything inside of here is built off of a template, so you can see kind of how this is going to create the shell of each of those web requests. For each of the web requests, you can see, basically it grabs the operation ID, the summary, all this information from the Swagger, and transposes it into this JavaScript template. And then you can see for each one of those endpoints, it customizes it with a transaction number and everything else. But it's also done another neat little feature inside of here. It's given us the ability to feed data in from a CSV file. So I've got a real simple CSV file. Let's say that I wanted to send a bunch of data in here, and I've got some test cases that I wanted to feed in. I've got a real simple CSV file that's got 2 columns, value 1 and value 2. Value 1 is what I want to send in, and then I'm going to pass that through the chained API, these 2 APIs calling the first one and then the second one, and here's going to be the value that I expect out. So if I send a 0, I expect it to respond, and then when I feed that into the second function call, it's going to uppercase it and put the little dashes in between it. So I'm going to use this as a template so we can see this has already stubbed out the ability to grab those parameters, and it's created some JavaScript that allows us to easily do it. Now the way this works is it uses a YAML file called parameters.yaml, and you can see here's where we're sort of binding those JavaScript variables to their particular parameters. So this parameter file is going to feed off of data.csv. As you can see, it's going to look for two values. There's the JavaScript value of value 1. It's going to look for column value 1. The JavaScript value for value 2 is going to feed in here. You can see that it's going to iterate through each of the values in that file, and then at the end it's going to loop and go back to the beginning. So this parameters YAML gives us a neat way for us to feed test case data directly from a CSV or an Excel file. So inside of here, I'm going to go ahead and instead of using a hard-coded value of 13, I'm going to go ahead and grab that value 1 here. And we'll go ahead and plug that right inside of here. The other thing that we've done is we've got the ability to grab our response from the first one, and we're going to go ahead and feed that into the second call. So instead of feeding in a hard-coded value, we're going to take what we received back from the response of the first call, we're going to feed that into the second call, and then that's going to be our second transaction. Now, the last thing that we want to do is a common assert statement, right? And so this example has also created a sort of assert, an assert where we can check the values that we're going to read in. So I'm going to uncomment these lines down here, and you can see we've got our first transaction that's going to feed from value 1, and then we're going to check the test case, which is value 2. That's going to be the expected result. So value 1 is going to get fed in to the first number to word function, and then the value from the first return is going to get fed into the second value, and that's going to get fed into this parameter here, and then we're going to compare what comes back as the response. So here's what we're going to do. We're going to create, we've got our two transactions independently. We're also going to do an assert statement. We're going to create another transaction that's basically going to say, okay, what value did we send in here? What value did we expect back? What did we actually receive in that second API call, fed from the first API call? Now, if those two values match, then we're going to go ahead and pass the transaction. And if those values fail, we're going to go ahead and fail the transaction. So what this is going to do, this is going to give us the ability to loop through this CSV file, feed all these values inside of here, and then audit them as to whether the transaction fails or passes. Now, one of the things, because I've been running this locally, there's also a results set. As I ran those DevWeb runs, you can see it created a directory here. We're going to run this as a real load test against my local machine. So I'm going to go ahead and delete that folder so that we get a brand new fresh copy of it. So now the other piece that we need to do in here is we need to edit our scenario. So what I'm going to do is I'm going to use one vUser, and let's run this for a total of maybe 10 seconds. We'll see how many items we can run through in 10 seconds here. So we'll go ahead and save that, and I think we're ready to go. We're going to go ahead and run this as a load run. And as you can see, it's feeding through, it's looping through the values of those functions. We'll let it run for the 15 seconds. I could bump up the number of vUsers again. The DevWeb toolkit allows you to run up to 50 vUsers locally without having to exercise a server. So you can see what's happening right now inside of this script is we're looping through those values. So we can see we start off with a 0 here, right? And we loop through that and we check to see if it's a 0. Then we come back and now we're moving on to the second row, which is a 1. You can see that 1 comes back and then it validates that. Now, if we look at these details, what we should see is 0, 1, and 2, I have coded the first 3 to where they should match. But you'll see on this third one, I've coded it to fail. Basically, we send in a 3, we're expecting it to uppercase this thing and put dashes between it, but I don't have this uppercase, nor do I have any of the dashes. So basically this line is going to fail. So let's go look at our results and see what actually happens. So everything that is logged inside of here gets logged to a database, and there's 2 types of databases, and I'll show you both of these momentarily. But right now I've logged this to a local SQLite database, and it's produced me a DB file here, which I'm going to go ahead and open this database. And if we pop this open, we will see in our SQL Explorer, we can go look at the transactions that were executed. And if we go ahead and pull these up, let me close this out so you guys can see this. Pull some of these files out. Here we go. So we can see here's the timing of each one of those functions. So we started the number to word function, and it ran for 124 milliseconds. We did the all uppercase with token function with 37 milliseconds. And then here was that assert statement. We sent a 0. We expected to see this. This is what we received. Therefore, the transaction passed. We do the same with the 1, the 2. And as you can see, the 3 has failed here, right? Because we sent a 3. We expected this value, but what we actually got was this. We hard coded it to fail, and now it has failed. So what we've got now is the ability inside of here to easily create a script that allows us to feed in data from a CSV file, executes through a series of web requests, and then assert what the values are, and do that all and log it to a database with a very simple SQLite interface. So I'm going to pause here for a second and show you a little more advanced topic, including a local Grafana database, so that we can duplicate what was happening on the server on our local workstation. Okay, so before the pause, you might remember we were working on our server, and we executed that script on the server. And one of the neat things the server did was it gave us a real pretty graph here where we could see sort of the throughput and hits per second and all of that information into a nice graph. So one of the things that we want to be able to do is, instead of having to upload this to the server, wouldn't it be great if we, on the developer's workstation, we could get a similar graph against this database that's being created here. So what I'm going to do is I'm going to start up a Grafana database here. So I have a Grafana dashboard that is local on my PC, and I'm going to go ahead and pull up this dashboard. And right now you can see that I've got a little network error because I don't have my InfluxDB running. But one of the things that I can do is if I run Influx on my PC here, and I'm going to go ahead and refresh this thing and make sure we're in good shape. Okay, so now I've got an InfluxDB running. So in addition to logging to this DevWeb database here, this little SQLite database that's going into the file system, I can also feed that data into InfluxDB and have Grafana graph this for me. So one of the things that we're going to do is we're going to change the little refresh rate here. We're going to refresh this to 1 second, and now it should be refreshing my data pretty rapidly here. The other thing I'm going to do is I'm going to go back over into my Visual Studio, and let's go into the scenario and let's run this. Let's ramp up the number of vUsers. So instead of doing 1 vUser for 10 seconds, let's run this as 5 vUsers, and we're going to go ahead and run it for 60 seconds. So now that we've got our nice functional script that does sort of a unit test with an assert, we're going to go ahead and test those sort of chained APIs, and then get all of our graphs and statistics into our Grafana dashboard. So I'm going to go back over here, save that scenario, go into our main.js, and we're going to go ahead and kick off this as a load run from my local PC again. So now we're running, we're pulling some data, and as you can see, we've got a Grafana database which is going ahead and pulling this up. So you can see we've started ramping up the number of V users here. Here are our transactions. So you can see we've got that all uppercase with token, and then we got our number to word function. This is starting to ramp up. And obviously you can see it cycling through each of the values here. There's a 0, a 1, 2, and a 3. In addition to that, now you've got all of your HTTP per second, your throughput, your bytes sent. So now you've got a console dashboard of what's happening on your PC, you know, as this script continues to run, and you've got a real-time interface viewing very similar data to what you would get if this thing were running on the server. So I'll pause for just a moment. Okay, at this point, you've now seen how easy it was to basically go in, create a load test, run that against your local machine. This is the developer doing it on their local machine, and now that they're satisfied with the results, let's talk a little bit about the second half of that function, which was pushing this stuff up to the cloud. So I've gone ahead and shut down my Grafana database. I'm going to close out my SQLite file, and you know, we're nice and happy with our JS script that we created. So I'm going to go back over here into my app.js. So again, you know, kind of two steps of the process. We were a developer. We've run step one. We've created our script. We've tweaked it, and now we're happy with the results. We're ready to push that up to the production cloud instance. So I'm going to go ahead and comment out step one. And let's go down to step two, and you can see beforehand, you know, we had this directory that was called Swagger example. We've edited the, you know, we've edited the main JS there to be a little bit different than before, and we want to go ahead now and push this up to the cloud and run this. You know, we're going to change the name of it. Instead of it being, you know, gadget script, let's change and put a new name called example script and example test. All right, so we're going to go ahead and save that. And just so we can look at the interface, let's go up to our load test. Here was that gadget test that we had run beforehand, and our you know, gadget script. You can see there's a couple other examples down here where we're pushing these to you know, pushing other types of scripts to the cloud, including Selenium and Gatling examples. But in this case, I'm just going to use that. I'm going to use that DevWeb that we created and, you know, ran locally and basically debugged locally, and know that it's a good script. It's ready to go, and I'm ready to run this in a production environment. So I'm going to call it example script and example test. We go ahead, go up to our terminal, run the task. We're going to do a node run. It's going to prompt us for our password. Enter that in, and as you can see, you know, one of the other things that I did inside of here is I also changed that push to cloud function. Instead of running as true, I changed that to be false. And so now what it's going to do is, instead of automatically kicking off the script, it's going to load it up to our asset library, but it's going to leave it there waiting for us to come and fetch it and do what we need. So if we go into our asset library and we refresh that, you'll see now that we have our example script here and a load test. It's an example test, you know, created with our 5 V users and 40 and bound to that particular script. And then when we're ready, we can come over here and we can run test, or we can call a different API to go ahead and run that off. And that's it. So the next piece that I'm going to show you are just some kind of housekeeping things. Obviously, you've seen most of the app.js here, but there are some other neat features. You don't necessarily have to run these from you know, from text inside of here and write the code manually. What I've also done is I've created a little piece here where I've created another JS file that if you're inside of the IDE and you want to parse a Swagger, it will actually call that toDevWeb function for you, feeding in the file. So let's go back up here again, right? And we'll go ahead and delete our Swagger example and get rid of that DevWeb script that we created. And let's say that we have this file right here. Here's a local copy of our Swagger JSON. And what we're going to do is, instead of hard coding an app.js to read that, we're going to use our IDE tools, and we're going to go up here, and we have created a profile that allows us to do a Swagger parse. So this will, if we look at this Swagger parse up here in our tasks JSON, or our launch JSON, task JSON, you can see we got our little Swagger parse. That's going to call that app swagger parse.js with the relative file that we're on, right? So if I'm, again, if I'm over here and I've got a quick JSON that I want to parse, I can go right up here to my terminal window, click on that JSON, go up here and say Swagger parse, right? And it will go ahead and call that toDevWeb function for me, and now it has created my main.js. Now finally, there's some last little goodies that are included inside of all of the DevWeb toolkit. One of the things, you might have a script that had been created in Gatling, or maybe Selenium or something along those lines, or maybe you just want to go ahead and use your browser and browse through an application and do a couple clicks and have the developer generate that to DevWeb code. Well, the developer doesn't have to know how to write that code by hand. One of the things they can do is they can go ahead. There's another little goodie inside of here that we've bound. It's called the ProxyRecorder, and one of the things that we can do is we can start up a ProxyRecorder, and in this case, you'll see that it's loading up a ProxyRecorder and it's listening on port 8156. Now, this is kind of like Postman or Fiddler if you've ever used one of those tools. One of the things that I can do is I can go right up here to my networking preferences, and I'm gonna go under Advanced, and under my proxies here, I'm gonna set up a web proxy, and I'm gonna have it point and go to 8156. So we'll go ahead, and right now what's happening is I've set up my IDE so that there's a listener behind the scenes that's going to log whatever I send through this proxy server, and it'll convert it into a DevWeb script for me. I'll show you sort of the process behind that. So what I'm going to do is I'm going to set up my regular Chrome instance so that if I go to an HTTP site, it's going to send all that traffic through this proxy, and then my IDE is going to record it and save it as a HAR file, and then we're going to generate a DevWeb script from that. So I'm going to go ahead and say OK and apply those settings. And now let's go ahead and put a new tab over here. And I'm going to go to automationpractice.com. This is a nice little website where people can use Selenium scripts. It's a very popular Selenium scripting site. It's just basically a test site where you can kind of test an example shopping cart application. So in here, I'm going to just click through a couple things. I'm going to click on this blouse here, and I'm going to add the thing to the cart, and then I'm going to go ahead and click proceed to the checkout. And as you can see, each time that I click something, the proxy recorder is capturing it here. So I'm going to go ahead and click proceed to checkout next. You can see it recorded a little bit more. And now what I'm going to do is I'm going to go ahead and stop my recorder. And what's happened is at the bottom here, it has created me a HAR file that contains all of the details of everything that I clicked on. So if I go ahead and close this, right, and close these details here, you can see that it's captured all of the traffic that I generated by clicking and moving through the proxy server. So now that we have that, we can take this to the second piece, which is we're going to go ahead and run that through what's called our offline generator. Our offline generator is going to take that HAR file, and then it's going to record that, and it's going to save that as a file. Let me see where it saved it. It saved it into a folder. It's called ProxyRecorder, and if we pop this open, you'll see there's a main.js inside of here, and each one of those steps that we took inside of the application, just browsing around, or maybe if we had an automated script that we ran, like a Selenium script or a Gatling script, it would capture the same thing. But you can see it's grabbed each of these, it's created our web responses with all of the resources that it needs in each of those cases, and it's written us a DevWeb script, stubbed out all the code that we need in order to duplicate exactly what that user did going through the cart. And all that was done right out of my IDE, basically running a task, capturing the proxy recording, and then generating that into a DevWeb script on the fly. So this concludes the gadget and the DevWeb portion of the video. But before we leave, I want to circle back to the slide that we talked about in the beginning. Most of this video has concentrated on the build side of the equation, the script creation and the text execution. But there's a whole other piece around analysis, and I'll throw out a couple teasers here. If you think about the human brain, humans are very good at deductive reasoning and sort of determine correlation and causality. So, humans can see a whole series of data sort of sorted out and figure out cause and effect relationships. But how do you use a computer to approximate that sort of capability and do it electronically? And that's where MicroFocus has a tool called Vertica that can help. And if you think about how most of data science works, right? It's you're observing something and you're trying to figure out what factors lead to that conclusion or that observation. So if you think about it, our Y in this case is our application response time, which is what's measured by Performance Center. And then you have all of your server or infrastructure metrics, which are measured by things like App Dynamics, Splunk, Dynatrace, any of the different server tools that keep track of how servers are performing, memory, CPU consumption, Java heap size, that type of thing. Well, Vertica is three things rolled into one. It's a SQL database along with AI, ML capabilities, and a super fast query engine. It can take data from all of these different sources and run it through a whole series of mathematical algorithms. So do data science on the fly. It can be hooked to visualization tools like Google Charts or Tableau. In this case, here's a visualization that kind of shows our microservice running and spiking at different points. And Vertica is able to look at all of the different factors that influence this application response time and do correlation analysis to see which things have the most overall effect on application response. And then it's able to run those through those models on the fly and see which one is the best predictor. For example, in this case, this random forest is a very good predictor because it's showing you the actual performance of the application in pink, and then what the random forest model has predicted would happen. As you can see, there's a pretty good overlay here. And the great thing about this is it can actually show you a set of dials that allow you to do what-if analysis without having to send the application back through a test cycle, changing the configuration. So you can just go in if you want to see how heap size is affecting the application. Just drag one of these sliders up or down, and it will recalculate what that will do for the response time. And you don't need to do design of experiments to figure out what metric is going to give you the best bang for the buck. So in many cases, it's kind of that consultancy aspect of what performance engineers do. Watch an application, see what's going on with it, and then making recommendations back to the developers or the configuration engineers to help them, performance tune. So that concludes our video. If you have any questions, please reach out to me, chris.young@microfocus.com. Thank you very much.